Okay, now let's discuss the concrete examples of inequalities. Solving inequalities. Okay, so to solve inequality, basically we want to find the corresponding solutions for the inequalities. And in this section, we will just study the linear inequality in one variables. Okay, linear inequality in one variables. Let's see, we discuss a strategy on example. Example, solve the inequality 3 minus 2x less than 5. Okay, so solution. First we have 3 minus 2x, 3 minus 2x less than 5. Our strategy is the following. We are going to keep x term in the left hand side, the numbers in the right hand side. 3 is a number, 5 is a number. 2 is not number, it's a coefficient. 2 is together with a 3. So you cannot use the 3 minus 2. That's totally wrong. 2 is together with x, not the 3. 2 is together with the x. This is one quantity. You do not do subtraction first. You do the multiplication. Okay? So you're going to move 3 to the right hand side. When you move it cross this relation symbol, cross the symbol, you're going to change it to be change the sign. This is plus. There's no sign, it's a plus. It becomes a 5 minus 3. Okay, so when you move it to the other side of equality or inequality, you're going to change the sign. Okay, negative 2x is negative 2x. 5 minus 3 is 2. Okay, and then you reach this step, ax is less than b. Ax is less than b. And you can divide or multiply this inequality by some proper number. When you say division, divide it by what? By this coefficient, by this negative 2. Because this is a negative number, you're going to change the direction of inequality. Okay, you divide the inequality by a negative number, you're going to change the direction. Because you divide by negative 2, this term cancelled. Negative 2 divided by negative 2 cancelled. You only have x. 2 over negative 2 is negative 1, so it is x greater than negative 1. Okay, so the solution set is x greater than negative 1. This is solution set. And here you say we can divide it by negative 2, or you can say we can multiply it by 1 over negative 2. The same thing. Division, multiplication, you only change it to the reciprocal. You change negative 2 to be the reciprocal of negative 2, that's it. Those two things are the same. The main thing is to simplify the left term and divide the whole thing by the coefficient. All right. So that's the complete steps. Okay, let's see another example. Solve the inequality 4x plus 7 greater than or equal to 2x minus 3. Okay, so solution 4x plus 7 greater than or equal to 2x minus 3. Like what we did, we want to keep x term in the left hand side, numbers in the right hand side. So 2x has an x term, so we move it to the left side. 7 is a number, we move it to the right. 2x, there's no sign, it is positive sign. Move it to the left, it becomes minus 2x. When you do this movement, you don't change the direction of inequality. So this is negative 3, you put a negative 3. 7 is positive 7. Move to the right side, it becomes negative 7. Right? So 4x minus 2x is 2x. Greater than or equal to. Negative 3 minus 7, negative 10. And then we are going to divide it by 2. This 2 is this coefficient. You divide this inequality by 2. Because 2 is positive, you keep the direction. So negative 10 over 2 is negative 5. Negative 10 over 2 is negative 5. So the solution set is bracket negative 5 and the infinity. Bracket negative 5 and infinity. So that's the second example. All right. So for all the linear inequalities, you can do this similar steps to completely solve it. Now let's see some combined inequality. Solve combined inequality. What is a combined inequality? Let's see the example. Solve the inequality negative 5 less than 3x minus 2 and less than 5. Graph the solution set. So two questions. Okay, so let's see how we do it. We do it in the following way. We copy this term. So this inequality contains two parts. This inequality, the left inequality and the right inequality. They follow some order. Okay. So how do we do that? We're going to apply some operation on the whole row. For example, in the middle, when the term has the middle term has x, but it also has a number 2. So we're going to add 2 to all parts. Negative 5, you add 2. Less than 3x minus 2, add 2. 1, add 2. It's a shift. It's a shift. So you add 2 to all 3 parts, you get the same inequality. And the negative 2 plus positive plus 2 is they cancel. So the middle term becomes 3x. Negative 5 plus 2 is negative 3. 1 plus 2 is a 3. Okay? And then we divide all parts. All parts means the left, middle, right. Everything, left, middle, right. We divide all parts by what? By the coefficient of x, by 3. Okay, so it becomes negative 3 over 3. Because this number is positive, you keep the direction of inequality. Okay, so it becomes negative 1 less than x less than positive 1. So that the solution set is negative 1, positive 1. To graph it, well, you put negative 1 here, you put positive 1 here. This is the graph. Okay. Let's see another example. We always try to do as many as possible examples in order to get a feel. Solve the inequality -1 less than or equal to 3 minus 5x over 2 less than or equal to 9. We solve this inequality, graph the solution set. Graph the solution set. Okay. Solution. How do we do that? We first copy it. Okay, so the middle term contains 5x. So we're going to simplify it until the middle term only contains x, no other coefficient, no other constant numbers. Okay? Okay, so the middle term is 3 minus 5x over 2. So we're going to multiply all parts by 2 to cancel this 2. So -1 times 2. This whole thing times 2. You cancel the denominator. 9 times 2 is 18. And then I'm going to handle this 3. We're going to subtract the 3 from 3 parts. Subtract the 3, so you get a -2 minus 3 less than or equal to 3 minus 5x minus 3 and less than or equal to 18 minus 3. -2 minus 3 is -5. 3 minus 2x minus 3 is -5. Less than 15. 18 minus 3 is 15. Now your middle term is -5x. The coefficient is -5, so divide all parts by -5. This is a negative number. You're going to change the direction of inequality. So -5 over -5. Here is less than or equal to. It becomes greater than or equal to -5x over -5. Greater than or equal to 15 over -5. Okay? And the rest of the step is a simplification. -5 over -5 is 1. -5 cancelled, x. 15 over -5 is -3. So x is between -3 and 1. The solution set is -3 and 1. You need to use a bracket because it has inequality. And you always write a small number first. Even though your inequality starts from 1, but when you write the interval, it's from -3 to 1. To graph it, okay, so this is -3 and 1. Okay? It's not very bad, right? Now let's see some more complex problems. Solve the inequality. (4x minus 1 to power -1 is greater than 1). Graph the solution set. Graph the solution set. Okay. We know that a positive, 1 over a positive, 1 over a positive, a positive. So negative power means 1 over the reciprocal. 1 over 4x minus 1 is positive. So 4x minus 1, the denominator is positive. Right? The reciprocal is positive, the original number is positive. And then you're going to move this negative 1 to the right side. If negative 1 moved to the right side, becomes positive 1. 0 plus positive 1 is 1. For x does not change. For x is not moved. You just copy for x. And this inequality, the left side, x has a coefficient of 4. You divide it by 4, you will get x. It is still greater than 1 over 4 because it's a positive number. Okay, so the interval, the interval notation is 1 over 4 infinity. If you try to graph it, you get 1 over 4 point, and this is a 1 over 4 infinity. So be careful about this reciprocal property. You flip a positive number, you get a positive number. You flip negative number, you get a negative number. Okay. Another example is an interesting type, creating equivalent inequalities. So if negative 1 less than x less than 4, find a and b such that a is less than 2x plus 1 is less than b. This problem is the inverse problem of this type. For you see, it looks like first you have the solution. You want to create a problem with a proper a and b. You see, the solution is between negative 3 and 1. You can go backward and get the problem. You get a is negative 1, b is 9. So that's the purpose. We have the solution. We want to create some problem so that the middle term is 2x plus 1. How do we do that? How do we be a teacher to create problem? So this middle term, it has 2x plus 1. So you're going to first multiply the inequality by number 2. Because 2 is a positive number, we just multiply the left side, right side by 2 and still keep the less than symbol. And then in the middle part, the middle term contains 2x plus 1. So you're going to add a 1 for 3 parts. Eight plus 1 is 9. Negative 2 plus 1 is negative 1. So a is negative 1 and b is 9. So you really create a problem by choosing a equal to negative 1, b equal to 9. You can find the solution x between negative 1 and 4. All right. And now let's see some application. This example, in electricity, Ohm's law states that E is equal to I times R. So where E is the voltage the unit is volts, I is a current, the unit is amperes, and R is the resistance. The unit is ohm. Okay, an air conditioning unit is rated at a resistance of 10 ohms if the voltage varies from 110 to 120 volts inclusive. What corresponding range of current will the air conditioner draw the corresponding current. Okay, so it's a simple application. We know that the voltage is between 110 and 120, and inclusive means it includes 110 and 120, so you have equality. This word inclusive means you can put equal sign. And we also know that E is equal to I times R. So I times R is E. I times R is between 110 and 120. And another condition is that this air conditioning unit has a resistance 10 ohm. So R is equal to 10. R is equal to 10, so like 10 times I, the current. Okay, now we have a linear inequality, a chain combined linear inequality. We divide those three parts by the coefficient of I, by this 10. 110 over 10 is 11. 120 over 10 is 12. So the air conditioner will draw between 11 and 12 amperes. Of current. Inclusive. You need to emphasize it is possible to be 11 or 12 amperes, so we use inclusive. Okay, so this section we review the interval notation. We also review the property of the inequalities, non-negative properties, addition properties, multiplication properties. We also get the complete solution for the linear equations, linear inequalities together with combined linear inequalities. Okay, linear and combined linear inequalities. Okay, and this is one of an example. Do your exercise and make sure you understand the steps behind them. Okay? Okay, now let's talk about the next section, 1.6. Equations and inequalities involving absolute value. Equations and inequalities involving absolute value. Okay, so first, solve the equation involving absolute value. When we have absolute value, for example, if we have absolute value of x is 10, then what we get? We get x could be 10, the principal, the positive solution, or x is negative 10, right? There are two solutions. If absolute value of x is equal to 0, there's only one solution, x equal to 0. Only for 0, there's one solution. Any other positive number, you have two solutions. Okay, to summarize it, we have that theorem. If a is a positive number, a is a positive number, then absolute value of u is equal to 0 if and only if u is a or u is negative. Okay, so whenever you have absolute value, you remove the absolute value, you will get either positive or negative a. Okay, here this u can be a number, you can be whatever expression, it can be very complex, but you have two choices. Let's see the example. Solve the equations. One, absolute value of x plus 4 is equal to 13. Okay, so in this case, this u is the expression x plus 4. X plus 4 absolute value is 13, then x plus 4, the internal stuff could be 13, or x plus 4 could be negative 13. The internal stuff you don't change. You see here, u is always u. You only get two choices, either the positive corresponding number or negative corresponding number. Between them, you use or. Okay, and x plus 4 is 13. You move 4 to the right side. If x equal to 13, it becomes minus 4. So x is a 9. 13 minus 4 is 9. Or here the similar thing, x plus 4 is a negative 13, x is negative 13 minus 4. You move 4 to the right side. Negative 13 minus 4 is negative 17. Okay, so the solution set is either 9 or negative 17. All right. A second equation, a second example. Absolute value 2x minus 3 and plus 2 is equal to 7. It's not in the standard form, but it doesn't matter. We can move 2 to the right side. It becomes 7 minus 2 is 5. So now you check absolute value is equal to 5. You have two possibilities. Either the internal stuff is 5 or the internal stuff is negative 5. okay? And then you move 3 to the right side, negative 3 to the right side. You got a 2x equal to 5 plus 3. 2x equal to negative 5 plus 3. So 2x is equal to 8. Or 2x is equal to negative 2. Divided by 2, you get x equal to 4. Or x equal to negative 1. Alright? Then the solution set is negative 1 and 4. Okay. Alright. Okay, so this is a solution to solve the equation involving ops value. Equation, you always have two choices. And now let's solve inequalities involving ops value. Inequality involving absolute value. Example, solve the inequality ops value of x less than 4. Absolute value of x less than 4. So what is the meaning of absolute value? Absolute value means the distance between the origin and x. The distance between the origin and the x. The absolute value of x less than 4, it means this distance, this length should be less than 4. So for example, if you put 4 here, and of course it's symmetric, you also have a negative 4. So the whole open interval, every point inside this open interval will have distance between the origin and itself less than 4. Sorry, I feel bad. Okay, so this symmetric interval. So hence the solution set is it's between negative 4 and positive 4. Okay, so when it is ops value strictly less than 4, the corresponding solution set is a negative 4 and a positive 4, the interval between those 2 points. The negative 4, we get a negative 4 because the distance between negative 4 and 0 is also positive 4. Okay? So this gave us the theorem. The theorem says if A is a positive number, like this number 4, then ops value of x less than a is equivalent to x between negative a and positive a. This is the interval x between negative 4 and positive 4, symmetric interval. Ops value of x is less than or equal to a, inclusive, so it's a negative a less than or equal to x less than or equal to a. Right? So this word means if and only if, or we mean equivalent. The left statement is equivalent to the right statement. Okay? So let's see the example. Again, here, the internal stuff may not just be x, it can be arbitrary algebraic expression. So solve the inequality (2x plus 4 less than or equal to 3). Graph the solution set. graph the solution set. How do we do that? We first copy this, and this is equivalent to this a combining inequality. So you copy this 2x plus 4, you don't change this, and put less than or equal to 3 and greater than or equal to negative 3. You put those two like limits on two sides. This is a combining inequality. We know how to solve it. We subtract 4 for all three parts. So negative 3 minus 4, negative 7. Middle term minus 4, you cancel 4, you get 2x. 3 minus 4 is negative 1. 3 minus 4 is negative 1. Okay? And then we're going to divide this inequality by 2. 2 is a positive number. We keep the direction. So 7 over 2 is negative 7 over 2 is negative 7 halves. Less than or equal to x, less than or equal to negative 1 half. So this is the solution set. The solution set is negative 7 halves, negative 1 half. Okay, and if you want to sketch it, negative 7 halves is a negative 3.5. So what? 0, 1, negative 1, negative 2, negative 3, negative 4. So negative 1 half is here. Negative 3 halves is here. This is the solution set. Negative 7 halves. Negative 1 half. Okay? This is a graph. See? Another example, solve the inequality. X value 1 minus 4x less than 5. Graph the solution set. Okay, solution. We first copy this inequality. It is less than 5, then its corresponding equivalent combining inequality is that you copy this middle term and put the bounds less than 5, greater than negative 5. All right, and then we're going to first handle the constant term, second handle the coefficient. We subtract 1 for three parts. Negative 5 minus 1, negative 6. 1 minus 4x minus 1 is negative 4x. 5 minus 1 is 4. And then we divide by negative 4. You have this coefficient. Coefficient is negative 4. You divide it by negative 4. Okay, because you divide the inequality by a negative number, you're going to change the direction. So negative 4x divided by negative 4 is x. 4 over negative 4. Negative 6 over negative 4. 4 over negative 4 is negative 1. Negative 6 over negative 4 is 3 halves. So the solution set is from negative 1 to 3 halves. You have to read it from smaller number to the large number. So the solution set is negative 1, 3 halves. The interval must comes from smaller numbers, ends at large number. Graph it. Okay, how do we graph it? 0, negative 1, positive 1, positive 2. 3 halves is 1 and a half, so it's this way, here. It does not include the endpoints, left endpoint and right endpoint, so it's negative 1, 3 halves in the middle. This is a solution set. All right. So we know how to solve it when ops value of a function is less than a positive number. Let's say the other one, when the ops value of a function is greater than a positive number. We see the example, ops value of x greater than 3. Absolute value of x is greater than 3. Let's sketch the graph. 0 is here. This is a 3. This is negative 3. Greater than 3 means the distance is bigger than 3. So you have to be either this part, this is greater than 3. Or symmetrically this part, this distance is greater than 3. Remember, whenever you do that, it is also always symmetric on the right side of a 0 and on the left side of 0 because you have absolute value. Absolute value does not depend on what side. It geometrically just measure the distance. All right, so this part means it has to be bigger than 3. The left part of negative 3 should be x is less than negative 3. So the solution set is either x is greater than 3, this right part, or x is less than negative 3. Or means you're going to do the union, and means you're going to do the intersection. Okay, so this is the solution set. Either from here to all the right, or from here to all the left. Two wings, two separate parts. Okay, so if you understand this example, we have the following theorem. If A is a positive number, then absolute value of x greater than A, it is equivalent to either x is greater than A or x is less than negative A. Greater than A or x is less than negative A. If x is greater than or equal to A, it's equivalent to either x is greater than or equal to A, here you put the equal sign, or x is less than or equal to negative A. All right? So this is the solution set for the inequality involving ops value greater than a positive number. So see the example. Solve the inequality. Ops value 2x minus 5 greater than 3. Graph the solution set. Okay, so solution. Let's copy this original inequality, and then this one has two parts. It's very similar to the equation involving ops value. It is either 2x minus 5 greater than 3 or 2x minus 5 less than negative 3. Either it's on the right side or it's on the left side in order to get the distance greater than 3, right? Okay, then you solve those two inequalities separately. So minus 5 greater than 3, we move 5, minus 5 to the right side is 2x minus 3 plus 5. You move to the right side, negative 5 becomes positive 5. 3 plus 5. Here, similar thing. You move it to the right side, it's less than negative 3 plus 5. So it's 2x greater than 8, or 2x is less than 2. Okay, then you do the division. Divided by 2, divided by 2. So x is greater than 4, or x is less than 1. The solution set is less than 1, negative infinity to 1, because it does not have equality, so it's a strictly less than, it's a parenthesis. Or means you have union. Greater than 4 is a full infinity. Okay, I'm trying to keep the smaller number on the left side, so that's why I consider this x less than 1 first. The bigger number on the right side, so I consider x greater than 4 on the in the second position. Between them, you have all, so it's a union. The graph 1 and negative infinity is on the left side. 4 and the positive infinity is the right side. This piece plus this piece. Okay, so you get these two pieces together. All right. Okay, so let's see some problem in the example, in the exercise, not example. We finished all the examples in the section. Let's see some additional exercise in this example. On page 134, problem 72. If absolute value of x plus 2 less than 5, then find a and b such that a less than or equal to 2x minus 3 less than or equal to b. Well, I use part of a 72 and a part of a 73. It doesn't matter, just get the you can solve it together in a similar way. So I combine those two problems together. Okay, you will see the steps. To solve this one, let's see. It's actually the combination of two problems. So first, x plus 2 ops value less than 5. It's a less than. Less than means you will have a combined inequality. So x plus 2 is between negative 5 and positive 5. There's no equals. Okay. Less than is between inside. It's close to the 0 origin. Greater than is outside. So that's why you have the left branch and the right branch. Okay, and you subtract 2 from all three parts. Negative 5 minus 2, negative 7. 5 minus 2 is 3. X plus 2 minus 2 becomes x. So this is a solution of this inequality. Inequality. But we don't need the solution. We need a and b. So you have to transform this to this type. Remember, we had the similar examples. It's like you know the answer, you want to come up with a question. So in the middle, it's a 2x minus 3. If we solve it, we handle constant term first, coefficient second. But if you want to create a problem, we handle the coefficient first, constant number second. So we multiply this inequality by 2. Okay, so you multiply all three parts by 2. All right, so that's the first thing. And second, subtract the 3. You see, you first handle 2, and secondly, you subtract this inequality by 3. Every place, 6 minus 3, negative 14 minus 3. Okay, and then you compare this with the problem. So A is negative 17, and B is equal to 3, and that's the answer. Okay, so you see here, this problem is a combination of two problems. One problem, you solve the inequality. Second problem, you create your own problem with this condition. All right, so that is the steps. Okay. Another problem is, for example, let's say 86. 86, we have x squared greater than or equal to 1. X squared is greater than or equal to 1. How do we solve this? It's solved by that you first take, let's put a 9 here, not 1. If you use 1, I don't see the, you may not see the rule. So you first take square root of this 9. You will get this equal to 3 squared. Then this equation x squared greater than or equal to 3 squared has two parts. Either it is very big or it is negatively very big. So either x is greater than 3 or x is less than negative 3. Okay, x is either greater than 3 or x is less than negative 3. Well, let me see. Okay, I just checked the Bosquejo file. This example is not considered in the exercise part, so let's skip this one. You will not see this problem in the exam. But I need to add the problem exercise 71 to 76 on page 134. Those exercises, add them to the Bosquejo file. Okay, so they are very useful and important. Try to add them to it. Okay, great. We finished the section 1.6 equations and inequalities involving absolute value. So keep in mind those two theorems. See, those two theorems, this theorem and this theorem, they are slightly different. If you have an inequality less than a, it is a combined inequalities. If you have inequality greater than a, you have two parts, either or. Okay, so they are different. Okay, great. Do the exercise. Make sure also do the problem from 71 to 76. If you have any question, send me an email. I'm happy to answer your questions. Okay, we finish this video and we will continue in the next video. Thank you.